Okay, so the last thing I want to talk about with inductive reasoning is a very common fallacy and a very important one that Gensler doesn't really talk about, but I think is worth covering because A, it is very hard for people to shake. Even I teach classes like this, even I have a little trouble shaking this sometimes. But it also really just does mess up inductive reasoning. So, let me give you guys an example. So, I flipped a quarter 3 times, I got heads 3 times, so I'm due for tails. So the odds I get tails on the next flip are way above their usual 50%. Is this good reasoning or not? I mean, obviously it's not, right? What I flip on the last flip has no bearing on the next one, right? They are random. One way of putting this is the coin has no memory. It doesn't know that it's come up 3 times as heads. Doesn't make it any more likely it's going to come up as tails. This is something called the gambler's fallacy. And you commit the gambler's fallacy when you treat independent events like they are not independent, like one has bearing on the other. Flipping heads this time on the quarter has no bearing on how the quarter comes up the next time I flip it. If I act like it does, that is the gambler's fallacy. When I say, okay, I've got 3 heads in a row, so I'm due for tails, that is the gambler's fallacy. Let me give you guys another example. Identical twins are not genetic. Look, identical twins, somewhat mysterious. We don't know exactly how and why it happens. But as far as they can tell, there is no genetic component, meaning it is not inherited. Meaning, if your dad was an identical twin or your mom or whoever, doesn't make it any more or less likely you will have identical twins. Identical twin, means when one embryo splits into two. I have identical twins. My dad was an identical twin, but it turns out that's just a weird coincidence, right? What are the odds I'd have identical twins given that my father was a twin? Well, odds for identical twins in any given pregnancy, they think is about 1 in 250. 1 in 250, 1 in 250, 1 in 62,500, right? These are independent. Thinking that it's any more or less likely that I would have identical twins is the gambler's fallacy. On the other hand, fraternal twins do have a genetic component. If your mom or dad was a fraternal twin, that's when you have 2 separate embryos fertilized, it does make it a bit more likely that you will have fraternal twins. Still not all that likely, but the odds go up. So if I said, well, if I said it's more or less likely that I'll have identical twins because my dad was an identical twin, that's the gambler's fallacy because I'm treating independent events like they are dependent. When you find out that my dad was an identical twin, that tells you nothing about how much or less likely it is that I will have identical twins because there's not a genetic element. On the other hand, if fraternal twins, that does tell you something that doesn't commit the gambler's fallacy. Now, look, the idea of the gambler's fallacy is simple. Think about whether 2 events are independent. If they are, don't treat them as dependent, right? If you go in a casino, a legal casino, they will make darn sure that the events in the gambling machines or the card tables are as random as they can be. Why? Because they'll get in trouble if they don't. Because if they're not random, it's easier for gamblers to predict them, and someone could make money. And more importantly, they can take your money without cheating, right? The odds always favor the casino. Over time, they will make money. They don't need to cheat. So if you go in a casino, you know that they have set up, say, the slot machine to be as random as it possibly can be. So if you lose 10 times in a row, it has not made it any more likely that you will win. Professional card dealers are very good at randomizing the cards. I guess you need to shuffle 7 times as a professional dealer, and then it is as random as it can be. They will do that. If you get a hand of complete junk playing poker in a casino, they shuffle and deal it again. The odds that you're going to get junk again have not went up or down, right? But the idea of the gambler's fallacy is completely tenacious. We'll talk about some examples in class, and you guys are going to make mistakes on some of these because everybody does. Before I started working on this stuff, I would make them too. It is a tenacious fallacy. It is hard not to fall into this sometimes. So why is that? I think it's because in a lot of cases, if seemingly unlikely things happen together, that would be good evidence that they're not independent, right? If you're playing with some random guy, you're playing cards with some people you don't know, and one guy keeps getting incredibly good hands, he gets 4 aces on one hand, which is not likely, a flush on the next hand, which is even less likely, and a straight on the next. Well, it's pretty good evidence that the dealer and this guy are probably cheating together, right? That is darn good evidence these events are not independent. And it's tempting to think like that in cases where you know the events are independent, right? In a casino, if this happened, I mean, I'm sure it happens sometimes, just because, if something happens enough, unlikely things will happen. But in a casino, you know the events are independent. They do not need to cheat to take your money, so they are not going to cheat. It is hard, it's hard to bracket that off sometimes when you know things are independent, but you have to avoid the gambler's fallacy. We will talk about this in class. We'll do a lot of exercises because the gambler's fallacy, like a lot of things with logic, the basic idea is not all that complex, all that hard to get your head around, but it can be hard to know when and how to apply it. Even if you know about the gambler's fallacy, there are some tricky cases that are easy to slip by. Last thing I'll say is this. Sometimes events aren't completely independent, but you can treat them as independent for practical purposes. Let me give you an example of this, right? Imagine that you and I are playing cards and I shuffle. I'm not good enough to cheat at cards, but imagine I shuffle the cards 4 or 5 times and, we deal, right? Now, you actually have to shuffle a deck 7 times for it to be completely random, for it to have no memory of the previous deal. And you have to be really good at shuffling. Vegas dealers, just like it's very, very random, right? I am not professionally good at shuffling. I'm pretty good. I shuffle cards. I actually do that. I'm going to guess I'm not professional level. Even if I were, 4 times is not enough for it to be completely random. But it is close enough, right? What was dealt on the last deal will have some impact on the next. but it's very small and it's incredibly hard to predict. You could treat those two as independent for practical purposes. The same is actually true for some gambling machines in a casino. It turns out that it is very, very, very hard to create completely random events, well, at all, with computers especially. So it turns out that what the machine rolled on the last roll has a very, very tiny, incredibly insignificant impact on what it'll come up with the next. I don't understand the physics here, but these things have random number generators, and apparently they're not entirely random because it's almost impossible to make something entirely random. The thing is, they are so close to random that there is no way that an honest person can take advantage of the fact that they're not quite random. I guess, and I know this because I read about it in the newspaper, if you cheat, there are ways you can take advantage of this and make some money. It's complicated, but for all practical purposes, you can treat rolls on the slot machine in a casino as independent because one has only the tiniest of tiny impacts on another. All right. Anyway, so that's the last I want to say about the gambler's fallacy. It is very tricky. It is hard not to commit this in some cases. So we'll talk a lot more about this in class. We'll do some practice just so you guys will get better at avoiding this.